Welcome to our second thermochemistry video. This video is about calorimetry. What is calorimetry? Well, the first part of the word is calorie, which refers to heat. The second part of the word is metry, which refers to the measurement of. Together, it means the measurement of heat changes during a chemical or physical process. In other words, what is the value of Q? In order to describe the value of Q, we must first talk about something called the specific heat capacity of a substance. You may notice that different substances have different abilities to heat up. Specific heat capacity is a measurement of how difficult it is to change the temperature of an object. If it is easy to change the temperature of a substance, it is said to have a low specific heat capacity. If it is hard to change the temperature of an object, it is said to have a high specific heat capacity. For example, let's compare two different substances, copper versus water. Copper has a lower specific heat capacity value. It has a value of 0.385 joules per grams degrees Kelvin, compared to that of water, which is 4.18. Because copper has a lower specific heat capacity, it will be easier to change its temperature. It will be easier to heat up. A more precise definition of specific heat capacity is the energy required to change the temperature of 1 gram of a substance by 1 degree Celsius. So that is the formal textbook definition of specific heat capacity. So how do we use this specific heat capacity value? Well, here is the equation that we would use if we were trying to calculate the heat transferred to a substance over time. Q equals m delta T Cp. The Q stands for heat, which is measured in joules and calories. M is mass, which is generally measured in grams. Delta T refers to the change in temperature, and it is the final temperature minus the initial temperature of that substance in degrees Celsius. And we just talked about the specific heat capacity, which is measured in joules per grams degrees Celsius or calories per grams degrees Celsius. Let's do a couple examples. Example 1. How much energy is required to heat up 20 grams of water from 30 degrees Celsius to 50 degrees Celsius? And the specific heat of liquid water is 4.184 joules per grams degrees Celsius. Well, the first thing we want to do is to write down the given variables. We know that we have to solve for the heat. We're trying to figure out how much energy is required to heat up the sample. So that is our unknown. We're given the mass of the water, which is 20 grams. We know the temperature change is 20 degrees Celsius since it goes from 30 degrees Celsius up to 50 degrees Celsius. And lastly, our given specific heat capacity is 4.184 joules per grams degrees Celsius. So first we write down our equation. Q equals m delta T Cp. Next, substitute in our givens. Notice how the units cancel out. The grams cancel out, and a degrees Celsius cancel out to leave behind the unit of joules, which is what we're looking for. We are trying to find energy, and energy is measured in joules. It's very important to write down the units, and we can see how they can cross-cancel out and be left with joules, which is what we're looking for. Okay, so let's simplify this, and our final answer, rounded off to correct number of significant figures, is 1670 joules of energy. So that's a very straightforward example. Let's do example 2, which involves copper. When 50 grams of copper is heated with 1046 joules of energy, the temperature increases from 10 degrees Celsius to 64.3 degrees Celsius. What is the specific heat of copper? Again, first thing we want to do is identify the givens. We know the energy that is absorbed is 1046 joules of energy. The mass of this copper is 50 grams. The change in temperature is 54.3 degrees Celsius as this block of copper goes from 10 degrees Celsius to 64.3 degrees Celsius. The specific heat of this copper, that's what we're trying to solve for. That is our unknown. So let's write down our equation. Q equals m delta T Cp. Substitute in our values with our units, and we simplify down. We can't cancel out any units yet since they do not divide out. Simplify, divide, and we get a value of 0.3 joules per grams degree Celsius. Again, none of the units cancel out. In the end, our units is joules per gram degree Celsius, which is what we want. Example 3. What is the final temperature when a 90-gram sample of aluminum at 20 degrees Celsius absorbs 500 joules of energy? The specific heat capacity value of aluminum is 0.897 joules per gram degree Celsius. Again, write down our givens. We have 500 joules of energy. The mass is 90 grams of aluminum. The change in temperature, we are trying to find the final temperature, so we are going to leave that as our unknown. Our starting temperature is 20 degrees Celsius, so delta T is TF, which is the final temperature, minus 20 degrees Celsius. The specific heat capacity of aluminum, we said, was 0.897 joules per gram degree Celsius. So let's plug this into our equation, and we are going to solve for delta T, and then from delta T we can get our final temperature. So we substitute in our energy, our mass, our specific heat capacity, and notice the joules cancel out, the grams cancel out, and we are left with degrees Celsius, which is what we want. We're trying to find a change in temperature. So we multiplied 90 times 0.897 to get 80.73. The units that are left are per degree Celsius. Now we divide both sides by 80.73 and we get a change in temperature of 6.19 degrees Celsius. Now this is not our final answer. We are looking for the final temperature, not the change in temperature, but the final temperature. So recall that delta T is final temperature minus the initial temperature of 20 degrees Celsius, and that change is 6.19. So then we just add 20 degrees Celsius to both sides and we solve for TF, and it comes out to be 26.2 degrees Celsius.